Congruence transformations are often called rigid transformations or isometry. It's one in which the position of the image may differ from that of the original, but the two figures remain congruent. So we talked about that congruent triangles are when I can manipulate one, spin it, flip it, move it so that it's on top of the other. These are the methods of which we can move it. So a reflection or a flip is the transformation of a line over a line called the line of reflection. Each point in the pre-image and its image are in the same distance from the line of reflection. So I would flip triangle ABC over the red line and it would land on top of FGH so that A would be on F, B on G, C on H. A translation or a slide is a transformation that moves all points of the original figure the same distance in the same direction. So that's literally like sliding the triangle across your paper. A rotation or a turn is the transformation around the fixed point called the center of rotation, through which the specific angle in a specific direction. Each point of the original finger and its image move the same distance from the same center. So I want you to pause. I want you to see if you can identify what A, B, and C is. So A is a reflection. We reflected over the line X. B is a rotation. We rotated it around the center O. And C is a translation, or we literally just slid it to the right. Now example 2. Triangle XYZ with those vertices is a transformation of triangle ABC with those vertices. Graph the original figure and its image, identify the transformation, and verify its congruence, that it's a congruence transformation. So I want you to pause and graph them both and see if you can identify what happened to them. And then we'll talk about how to verify they're congruent. Okay, so I started off with triangle XZY or XYZ, which is blue triangle. And then I also graphed the pink triangle, which is ABC. To me, it looks like a reflection. And it looks like triangle ABC is congruent to triangle XZY. Now, in order for these to truly be a congruent, I have to verify that all the sides are congruent. It's the only thing I can do on graph paper. So in order for these to be congruent, I need AB to be congruent to XZ, BC congruent to ZY, and AC congruent to XY. And on graph paper, we're always using side, side, side. So again, to confirm their congruence, I'm going to use the distance formula. So reminder, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So I want you to pause and see if you can tell if these are congruent. So you can see that I found AB and XZ are both the square root of 17, so they are congruent. BC and ZY are both the square root of 29, so they are congruent. And AC and XY are both the square root of 40, so they are congruent. So yes, this is a reflection, and the triangles are congruent. So example 3. Triangle JKL with those vertices is a transformation of PQR with those. Graph the original and its image. Identify the transformation and verify. So I want you to pause and do all of this and then come back and check. So I graphed them and I found that PQ equals square root of 45, which JK also equals square root of 45, so they're congruent. QR equals square root of 17. KL also equals the square root of 17, so they're congruent. And PR equals the square root of 20, which is equal to JL, which equals square root of 20. So triangle PQR is congruent to triangle JKL by SSS, and the transformation is a rotation. So tomorrow we'll work on this section in class. If you have any questions, please jot them down.